hearing me. Hello, 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 Miss Cora. Thank you so much for joining. Please share the live. Please share the live. Let me know if you're hearing me okay. Let me know if you are hearing me okay. I have a little bit of background noise, but let's see if we could work with that. How are you? How are you? How are you? Today, I'm going to do a very short live. It's going to be very short today, but we are going to talk about vaccines, and we are going to talk about how vaccines are made, how vaccines work. We're going to talk about what we do with vaccines, and we're going to talk about how vaccines are, why we are having such a rush for vaccine. Thanks for answering, Natisha. Thank you so much for answering. So yes, so we are going to have a little discussion today about vaccines and about how they function, whether we should be afraid of them, whether they are common, whether we use them generally, because we're having so much discussion about vaccines now, particularly as it relates to COVID-19, that we need to have the discussion. We have to have the discussion. So this is a situation. This is a situation. I'm going to first start by asking a couple questions. So for those of you who are tuning in, here's my question to you. Have you ever had a vaccine? Have you ever taken a vaccine? Have you ever, do you know anybody who has taken a vaccine? Let me know. Let me know so that we could talk about what that experience has been like also, because we hear people talking about doing the flu vaccine and that kind of thing. Again, good afternoon, everyone. Continue sharing the live, continue sharing the live, continue joining as we go along. So yeah, I think one of the things, because I don't want this to be too long, I'll jump right into it. One of the things that we are not conscious of is the fact that vaccines really have been a part of our lives for quite a while. And because, thank you, Natisha, for answering. And because we live in Trinidad and Tobago, we actually have very high rates of vaccine use. Tammy is saying yes, and it makes some people sick upon taking it. So yes, we will actually talk about why it makes some people sick when they take the vaccine, when I explain how the vaccines work. Okay, so we would get to that about why some people actually feel a little ill when they get vaccines. But let me share some information with you. Quite a bit of what I do today would be sharing my screen and sharing the some videos. I hope it works. I hope it works. I haven't done it with this system before. So what we're looking at here is actually a WHO website that is relating to Trinidad and Tobago. And what we are seeing is that Trinidad and Tobago actually has quite a bit of vaccine uptake over the years. The last couple of years we look at would be 2018 and 2019. So if you look here, this is the percentage of our population within 2018, 2019 that has had the different kinds of vaccines, right? And if you are seeing here, we are in some years 90%, 91%, 99%, 92%, 99%, 93%, and so forth. So this basically shows that Trinidad and Tobago actually has been an entity or a country where vaccine use is quite normal. As a matter of fact, if you are aware, for you to For you to enroll your child in primary school, for example, you have to show them your immunization card. And your immunization card is vaccines. That is what your immunization card is. It is the card that shows that as a child, this child took these different vaccines. And these are all the different kinds of vaccines that we usually take in Trinidad and Tobago. We have the typhoid, tetanus vaccine. We have hepatitis B vaccine. We have measles vaccines. We have pneumococcal conjunctivitis prevention vaccine. We have polio vaccine. We have all of these different types of vaccines because that is how vaccines were created many, many years ago to help us be well and to help us survive a lot of these diseases that the vaccines are there to prevent, right? So vaccines have been part of our healthcare system. Vaccines have been part of our system generally for quite some time. We are just as adults hearing a lot more information about what is in the vaccine and so forth, or we are also hearing a lot of conspiracies about vaccines coming from other areas. Now, the reality is a lot of those conspiracies have not been proven. And even though, as Tammy said here, that, they do make you sick sometimes, they do make you sick because of how they function. I don't know that that is a good reason just yet to not take the vaccine because of the benefits of the vaccine. So I'm talking generically now. And as you can see here, we're talking about these kinds of vaccines that we take in Trinidad and Tobago. We take them as children. Now, to show you how well these things work, I'm going to ask any of you, like the polio vaccine. When last you heard somebody died from polio in Trinidad and Tobago? Polio was one of those diseases that kill you dead. When last you hear somebody die from polio? When last did you hear somebody die from measles? Because measles is also one of those diseases that kills you. When last have you heard people dying from any of them from hepatitis B? Now, the reason we are not hearing about deaths in those from those diseases is because we have been taking the vaccines, and as you see here, the percentage of the population that has taken the vaccine is actually pretty high, 90%, over 90% for practically all of them. As a matter of fact, Trinidad and Tobago boasts of being one of the countries with the highest rates of vaccines, with the highest rates of vaccine uptake, meaning our healthcare professionals, the doctors, the nurses, whoever, they have been the ones who have been able to push vaccine use. And because we've had such high uptake of vaccine, we have very limited child mortality, meaning children who die from those diseases, or infant mortality, meaning children under the age of 1 who die from those diseases. Stephanie is saying vaccines have been working forever. Exactly. They have been working forever. Tammy is saying for vaccine to work, your body should be able to fight off the infection. So we're going to go into a clip, and I hope this works. So let me pause for a second. Guys, share the live. Let me pause for a second to say that. So I've been doing these Facebook Lives. I'm using a particular program on the computer. So it's a website, a streaming website. I switched from one streaming website. So even though you are seeing this on Facebook, I am actually doing this via another website to get it to Facebook, and it's streaming to Facebook. So I was using one before, and I wasn't happy with some of the things that were happening. Like before, when I would try to share my screen and I tried to invite guests, it was not working. So I switched from one to the other, and I'm still kind of new with this one. So let us pray that this works, because I have a couple of videos I want you all to see. And let's hope that the videos work. All right, let's hope that the videos work. So what I want to jump into right now is basically a video about how vaccines work, right? It's a video about how vaccines work, and let me see if I can pull it up. And hopefully these are all YouTube videos, as you're saying, these are all YouTube videos about how vaccines work, and let's hope that you can get the audio from them when I pull them up. Let me know if you're hearing the audio from this. So I'm pausing it there a little bit because I want to ensure that everybody's actually hearing the video. So type in the chat whether you're hearing the video or you're not hearing the video. Stephanie said. So let me not hearing anything good. So let me try this one more time. Let me try this one more time. And see, as I said, I have to make sure that it works because this is something new. So let me see here. Screen, application, this one. So I am trying again. Please forgive me. This is an option that now says share audio. So let me, hopefully it works this time. And I feel like I have to share. Let's see here. So what you are now seeing is everything that is on my screen, but I am going to have to do this a little bit differently to make sure that it works. Are you all hearing the audio now?
In 1796, the scientist Edward Jenner injected material from a cowpox virus.
So tell me, type. Are you hearing the audio? Are you hearing the audio? Tell me now, are you hearing it? Yes, you are. Okay, so I'm going to have to figure out how to do it that way. And share the screen with that. So, hey, we're working this out. We're going to get it done. And we just have to figure out how to do it. All right, cool. So here we go.
In 1796, the scientist Edward Jenner injected material from cowpox virus into an 8-year-old boy, with a hunch that this would provide the protection needed to save people from deadly outbreaks of the related smallpox virus. It was a success. The 8-year-old was inoculated against the disease, and this became the first ever vaccine. But why did it work? To understand how vaccines function, we need to know how the immune system defends us against contagious diseases in the first place. When foreign microbes invade us, the immune system triggers a series of responses in an attempt to identify and remove them from our bodies. The signs that this immune response is working are the coughing, sneezing, inflammation, and fever we experience, which work to trap, deter, and rid the body of threatening things like bacteria. These innate immune responses also trigger our second line of defense, called adaptive immunity. Special cells called B cells and T cells are recruited to fight microbes and also record information about them, creating a memory of what the invaders look like and how best to fight them. This know-how becomes handy if the same pathogen invades the body again. But despite this smart response, there's still a risk involved. The body takes time to learn how to respond to pathogens and to build up these defenses. And even then, if a body is too weak or young to fight back when it's invaded, it might face very serious risk if the pathogen is particularly severe. But what if we could prepare the body's immune response, readying it before someone even got ill? This is where vaccines come in. Using the same principles that the body uses to defend itself, scientists use vaccines to trigger the body's adaptive immune system without exposing humans to the full-strength disease. This has resulted in many vaccines, which each work uniquely, separated into many different types. First, we have live attenuated vaccines. These are made of the pathogen itself, but a much weaker and tamer version. Next, we have inactive vaccines, in which the pathogens have been killed. The weakening and inactivation in both types of vaccine ensures that pathogens don't develop into the full-blown disease. But just like a disease, they trigger an immune response, teaching the body to recognize an attack by making a profile of pathogens in preparation. The downside is that live attenuated vaccines can be difficult to make, and because they're live and quite powerful, people with weaker immune systems can't have them, while inactive vaccines don't create long-lasting immunity. Another type, the subunit vaccine, is only made from one part of the pathogen, called an antigen, the ingredient that actually triggers the immune response. By even further isolating specific components of antigens, like proteins or polysaccharides, these vaccines can prompt specific responses. Scientists are now building a whole new range of vaccines called DNA vaccines. For this variety, they isolate the very genes that make the specific antigens the body needs to trigger its immune response to specific pathogens. When injected into the human body, those genes instruct cells in the body to make the antigens. This causes a stronger immune response and prepares the body for any future threats. And because the vaccine only includes specific genetic material, it doesn't contain any other ingredients from the rest of the pathogen that could develop into the disease and harm the patient. If these vaccines become a success, we might be able to build more effective treatments for invasive pathogens in years to come. Just like Edward Jenner's amazing discovery spurred on modern medicine all those decades ago, continuing the development of vaccines might even allow us to treat diseases like HIV, malaria, or Ebola one day.
Okay, so we got that. Vaccines are made by several different techniques, but the basic idea is that they are causing your body to have the immune response even before you come into contact with the disease. So when you finally come into contact with the real disease, your body already knows what to do. Your body already has the antibodies built up, waiting to respond. So it's like sending in an army when the army already knows who the warrior is, where they're coming from, what direction they're coming from, and so forth. That is what we are doing when we give vaccines. As you saw there, because your body is learning how to fight the vaccine, learning how to fight the disease that the vaccine is building it up for, for some people, when they get the vaccine, they actually do feel sick because your body is actually going through the process of how it would normally function to develop antibodies for the vaccine. So you may have tiredness, you may have sore throat, you may have all of those things that you normally feel when you are getting sick, because that is how your body responds to this external thing that it is trying to fight off. So yes, taking the vaccines, for some people, they don't feel anything, but for some people, they feel pretty sick. And I know that that has been a deterrent for some people because they tell you, I was fine before, and it's only after I take the vaccine that I get sick, and that is counterintuitive. But the reality is, I think that happens because we did not explain to people ahead of time that you may actually get sick. You may actually feel a little bit sick, but that is actually sign that the vaccine is doing what it should be doing. Okay, so I just wanted to take a little bit of time to explain that part. Let me find another video that speaks specifically about the COVID-19 vaccine, because that is why this whole thing is coming up. That is why this whole hoopla is coming up, because people are now talking about the fact that we have a COVID-19 vaccine, or we will have a COVID-19 vaccine. And if you're in Trinidad and Tobago, within the last day or two, the Minister of Health made a comment about spending a whole lot of millions of dollars for a COVID-19 vaccine, but we know that they don't have any vaccine available just yet, and all of the hoopla about that. So I wanted to take a little bit of time to just show you another video which speaks about specifically the COVID-19 vaccine that we don't have yet, but it is in development, and why development of the COVID-19 vaccine is actually happening so quickly. What is different about that versus this? Let me say though that particularly as it relates to COVID-19, we have been, remember, this is something that is new, and we have been going through the process of having different people say different things at different times. In some instances, we have the same people saying different things at different times. You have WHO saying one thing a month ago, saying something else 2 months ago, saying something else 3 months ago. And what we are experiencing, and quite frankly, I think it's a blessing, we are experiencing the fact that we have science happening very quickly right in front of our eyes. We are experiencing a scientific infrastructure that we did not have before. So we now have a situation where a lot of the things that we are experiencing in terms of the scientific knowledge that causes us to change our protocols or causes us to change our recommendations for what to do and what not to do with COVID-19 is because we are learning new information all the time. And personally, I actually feel blessed to be in a time where we are learning all of this new information so quickly. See, what has happened before is that it would take years to learn all of the things we are now learning in such a short space of time. So you don't even notice that they're changing what was said, because you said something this year and it's not until a year or 2 years later that you make the change. When in fact, as it relates to COVID right now, you say something this month, and by next month, we are learning something different, something new. So you change the protocol, you change the recommendation. So I'm asking us to not get frustrated too much or too quickly about that, because we need to allow the science to function. And any good government, any good organization, whether it's the WHO, the CDC, whatever it is, when they get new information, it is their responsibility to bring that information to the people, even though it contradicts completely what they said last month or the month before, because they now have this new information. All right, so let me let you see this other video about how the COVID-19 vaccine is created and why it is happening so quickly for us. Again, you're going to see a whole lot of stuff on the screen because I have to share my entire screen for this to work. So you actually seeing what I see in the background, and then I'm going to switch over. All right. So let me switch over to this.
Scientists at the National Institutes of Health are working to create a vaccine for the new coronavirus that originated in China. But they're not starting from scratch. They're employing an approach called vaccine rapid response platforms.
It involves high-tech methods that have the potential to shave years off of development time. Ideally, they'd offer protection while an epidemic was still spreading, instead of years later.
Within weeks of the world learning about the Wuhan outbreak, Chinese scientists uploaded the novel coronavirus's genetic sequence to a public database that allowed teams around the world to start designing a vaccine. Traditional methods require an actual sample of the virus. Typically, scientists inactivate a virus using special chemicals before it's put into a vaccine. When the inactivated or weakened virus is injected into the body, the immune system recognizes it as a foreign invader or an antigen. Vaccines use antigens to prime the body to protect against a particular virus. But vaccines developed with rapid response platforms work differently. Rather than directly injecting antigens into the body, these types of vaccines typically send instructions to cells in the body. It gets the cells to produce antigen proteins that are specific to the virus it's designed to defeat. These instructions are in the form of RNA or DNA, the molecules that contain the code for building proteins. Scientists say this process cuts down on development time because they don't have to grow the whole virus. Plus, when scientists identify and create the instructions for one virus, they can tweak those instructions to make a vaccine for a similar virus.
So think of the backbone as a set player, and the new virus sequence of our target, like from the new coronavirus, that sequence that we design in, think of it as a new cassette tape. So you can just slot it in.
You can slot in new virus antigens.
Melanie Sawville is the Director of Vaccine Research and Development at the Coalition for Epidemic Preparedness. CEPI is a global partnership that was launched at Davos in 2017.
We were actually formed specifically to look at this type of situation.
In this situation, the emergence of a new coronavirus, CEPI is funding several teams from around the world that Sawville says are each independently working from the platform model.
The sort of technologies that we are looking at, but some of which are really quite pioneering, can really move very quickly.
3 of the candidates are in a category called nucleic acid vaccines. One of those candidates is Moderna, which is working with the NIH. They're developing a vaccine on a platform that uses a part of the virus's genetic code called messenger RNA, or mRNA. So again, unlike the conventional approach, with mRNA vaccine platforms, it's our own body cells, rather than lab techs, that produce the antigen proteins that are like the ones made by the coronavirus.
Your immune system then will be stimulated and develop antibodies to the virus, so that when you see it again, it can immediately recognize the virus and prevent you from becoming sick.
More and more people are becoming sick from the novel coronavirus. As the race for a viable vaccine continues, public health officials don't know how bad the situation will be by the time they hope to have a vaccine ready for widespread distribution.
Normally, vaccines will take years to get into the clinic, so the sort of technologies that we are looking at can really move very quickly. So an example of that is getting from identifying the sequence of the virus to developing the vaccine, doing all of the preclinical testing, manufacturing, and getting into the clinic in 16 weeks.
So around 4 months. During the 2003 SARS outbreak, that process took 20 months. Experts say if one of the 4 teams CEPI is funding is successful, it would be a watershed moment for human health.
These are
So there you have it. We now have a full new kind of technology that is available for developing these vaccines. And the first part of it, the first part includes them not having to take the vaccine and have to regrow it themselves, because they were able to find the genetic material, the genetic code of the vaccine very early because of, again, advancements of science. They basically skipped an entire step that would have normally taken a lot of time. So the reality is, no, the vaccine is not available yet. And even though vaccines normally take years before it becomes available, the one for COVID-19, because of that initial step and because of the technology that they're using for vaccines now, is going to be available much sooner. Now, I don't think it's going to be available by November, as purported by a certain leader of the free world, but it is going to be available by mid to late next year, where larger volumes of people can have access to it. Now, one of the things they usually do too is when they go through all of the tests, meaning they go through the tests of making sure that they create it, making sure that it's safe, putting it in large volumes of people, following them, making sure that they're fine, then they can send it out and ensure they can send it out. And what they tend to do is vaccinate those people who are most at risk. So we know that the elderly are most at risk. The elderly, if you have another precondition, meaning you have a comorbidity, you have diabetes, heart disease, something else that makes you more likely to die if you get COVID-19. So somebody like that, they would give the vaccines first. Health professionals. One thing that we have not been thinking about here in Trinidad and Tobago is the fact that in the United States and a lot of other countries, a lot of the people who get COVID-19 and die from COVID-19 are actually healthcare professionals, because they work in the hospital where people with COVID come in all the time. So vaccinating the healthcare professionals would also be one of the first groups of people to get vaccinated when it is available, when it becomes available. So that's why it is, they seem to be going very quickly. But again, it's because we have the technology. We are in an era where we have a scientific infrastructure that allows us to do these things, and to do these things much faster than we've been doing them before now. We have the technology that allows us to do them much faster than how we've been doing them before. So one of the things I want to do now is to have you look at exactly what the Minister of Health said yesterday or day before in his presentation, because his pronouncement is part of why there was such a hoopla about the vaccines in Trinidad and Tobago, because he made a presentation in the House in response to the budget. This was part of his budget presentation. Now, because the budget presentation is very long, blah, 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 instead of going directly to his presentation in the budget, what I've done is actually pulled out a TV6 news report of what he said. And basically, I thought it was a nice summary, particularly as it relates to the COVID-19 vaccine and what he said. So again, you're going to see a whole lot of things on the screen. I promise that by the time I get to my next Facebook Live, I would figure that part out, how to not have you see all of this madness that I am looking at on the screen. But what you're going to see after that is me going to that TV6 report and playing it so that you get a sense of what the minister actually said versus what was reported. Because in many instances, I'm seeing kind of a misunderstanding of what he said. All right, so sharing the screen again and going to what he said.
The government of Trinidad and Tobago, by cabinet note and cabinet decision, has allocated $9,741,237 US, or $66,142,999.23 for the purchase of vaccines.
The saying, your health is your wealth, rings true more than ever in 2020, with government already expending $79 million taxpayer dollars in the fight against COVID-19. And as an effective COVID-19 vaccine is our best chance at regaining a semblance of the old normal, that opportunity will, in due course, be afforded only to those who need it most, at least in the first instance.
Under the COVAX facility, built on the principle of equity, all countries will get an initial amount of doses to vaccinate 20% of their population. Elderly, immunocompromised, healthcare workers. For us, that translates into 280,000 doses. And then we get the balance.
In total, government has ordered 462,000 doses of vaccines through the COVAX facility, which represents roughly 33% of our population. But TNT is also looking elsewhere to boost our supply.
Outside of that, because we want to have as many irons in the fires as possible, we are also having separate talks with Sinopharm out of China.
While no date has been given for the arrival of these vaccines, which are yet to be approved for safety, the state is preparing for that eventuality.
One or two of the vaccines in trials have to be stored at -60. What we are doing right now is looking at the range of storage conditions for the vaccines to build 3 purpose-built walk-in chillers and to keep these vaccines off-site. They will not be at C40. We'll back up with solar energy and diesel.
The vaccination drive is just one leg of the state's plan to move TNT from community spread back to cluster stage. At present, our daily rates of infection are decreasing, but our mortality figure continues to rise.
The global average is around 2.93. Our rate is 1.72. So we are way below the global average in our case fatality rate. 1 death is too much. But compared to what is happening in the world, we are way below the global average.
Renessa Cutting, TV6 News.
So, that tells you. What he is basically saying is what COVAX is, and I'll show you another very short video explaining what COVAX is. So what we have done is bought into a worldwide initiative to ensure that when the vaccine becomes available, whenever that it is not just given to the wealthy countries, because usually what happens is when these things become available, those people who have money, as is usually the case for most situations, those countries that have money, they can bid and outbid the countries that don't have enough money. So the COVAX is kind of like a worldwide agreement that says, because this is so important to all of us, and because we are doing this at a worldwide level, that we're going to do bulk buying, bulk procurement, and then equitable distribution. So the countries that can pay a lot for their pay a lot into it, they would be able to pay into it. The countries that just don't have enough money to pay into the system, they pay in what they can, but at the end of the system, because we see this as a worldwide community, at the end of the system, at the end of it, everybody gets equal access and not just those who can afford it. So what I'm going to do now is to just show another little video that speaks a little bit about the COVAX system and why the Trinidad and Tobago is a part of it. Now, you all know me. I have been very critical about how the government has responded to COVID-19 when I needed to be critical. And I have been very honest in my assessment of how the government responds. Now, this is one of those times that I think in my mind, I am being fair in my assessment, because if I were in charge of health, I would have done the same thing, because this really is a worldwide initiative that we need everybody to be a part of. Again, disclaimer, screen will be mad, and then you go to the important parts.
When the world has safe and effective COVID-19 vaccines, how can we make sure they reach the people that need them most? Today, there are many vaccines in development. Most will fail. For those that could succeed, governments are under pressure to secure supplies for their populations. If governments compete for vaccines, most countries could miss out. This is not only bad for countries that cannot secure their own supplies. It's bad for us all, as no one is safe until everyone is safe. The COVAX pillar aims to ensure that every country gets fair and equitable access to eventual COVID-19 vaccines. It does this by acting as an insurance policy, with the largest portfolio of vaccine candidates in the world. Wealthier countries have a greater chance of gaining access to successful vaccines. And by pooling their buying power, rather than competing against one another, they enable investment in factories. So more doses are available as soon as a vaccine becomes available. The COVAX pillar is founded on the principle of equitable access. This means any country, regardless of their ability to pay, has the same access to vaccines. By supporting the development and manufacturing of these vaccines, wealthy countries increase their chances of getting COVID-19 vaccines and ensure the rest of the world gets access too. Ending the pandemic as quickly as possible will take a global effort. We need as many doses as possible, as fast as possible, as soon as a safe and effective vaccine becomes available. 2 billion doses would be enough to vaccinate healthcare workers and other high-risk groups. If we start now, we can save hundreds of thousands of lives, not to mention trillions of dollars. It's not about one country versus another. It's about one world protected.
So there we have it. That is what COVAX is about. It really is a WHO World UN initiative to ensure that all of us have access to the COVID-19 vaccine when it's available. Of course, like anything else, no one is going to force you to take the vaccine if you don't want to. But when we look at the high rates of mortality, meaning death, and when we look at the high rates of morbidity, meaning how sick people get and how sick people in these groups get, the elderly, people with other diseases, people who are immunocompromised, meaning they have maybe HIV or they have some other disease that is causing their immune system to not function. When we look at how badly those people can be affected by COVID-19, I think it would be worth taking the vaccine in the long run, as long as we are clear that the vaccine has actually gone through the processes of being developed safe, and that when we use them in the small quantities in clinical trials, the results are good in the clinical trials. Recently, we actually heard the federal FDA, Food and Drug Administration, say that one of their requirements as it relates to determining whether a vaccine can go on the market is getting 2 full months worth of data from people who have taken the vaccine, and that they were not willing to compromise on that, because one of the things that was said is that the vaccine would be available very quickly by November. And the FDA came out very strongly and said, no, it will not, because we are not going to approve any vaccine unless we have at least 2 months worth of data showing that it is safe, that there are no really, really bad side effects or anything like that. Right? So that's one of the reasons why I think it's critical for us to understand what is happening in the world. And it's critical for us to not just jump on some of these bandwagons where they speak about, we're so quick to jump on a thing about nobody wanting to take a vaccine. I actually saw somebody say, nobody wants a vaccine. And I'm thinking, well, I don't know that nobody wants a vaccine, because many of us are alive now because we took vaccines. Many of us are alive now because as children, we were vaccinated. And I don't think many of us understand that when we talk about immunization in childhood immunization, that it really is a vaccine or different vaccines that we've gotten as children. And the fact that we survived all the way to now is proof that the vaccines are not killing us. As a matter of fact, what we are seeing in the United States is actually a reversal, because there are a lot of these conspiracy theories basically about why we should not take vaccines. And because of that, there are a lot of people who are not vaccinating their children for measles and mumps and all of those things that we've been vaccinating our children. And you now have very high rates of measles death in the United States. And it's the weirdest thing, because not dying of things like measles, polio, and so forth is proof that you have decent health care. And the part of the health care that is decent is the ability to vaccinate children at a very, very high rate. So we have people who are out there spewing misinformation about vaccines and causing a lot of people to not want to take the vaccines when it is actually the same vaccines that has allowed them to live to be old enough to then spew misinformation about vaccines, right? I want to do one more video quickly, one more video about herd immunity, because that is something that comes up very often. So this video is about herd immunity, which speaks to the idea of why we need more than why we need a high enough proportion of people to be vaccinated for it to work. And that is what has happened in Trinidad and Tobago. So when we see the high rates of vaccinations, the 90-something%, because those 90-something% people have been vaccinated, it means that those who were not vaccinated are being protected because of herd immunity. Tammy is saying that I think that the Ministry of Health needs to do is to try and promote the effects and usage of vaccines for years, because the population has been vaccinated. Yes. So I do think that the Ministry of Health needs to do a little bit more in promoting it and a little bit more in educating, because we suddenly have this, oh my God, anti-vaxxers, as Stephanie says. The name for those is anti-vaxxers. They're suddenly anti-vaccines, but vaccines have been there and we've all been vaccinated, most of us anyway. I know as long as you've been to a secondary school in Trinidad and Tobago, a primary school in Trinidad and Tobago, you will vaccinate it, because it's one of the requirements that enter into primary school. You have to be vaccinated, because they don't want you coming to school not vaccinated and then picking up measles, mumps, and polio and all of those things. So I'm going to share one last time the video that discusses what herd immunity is, and then we're going to have a little wrap session. You could ask any questions and I will try to answer them, and that'll be it for today. All right, so let's see here.
In the absence of vaccination. First of all, let's observe the progression of a disease in a naive population, meaning a population that has never been exposed to a disease-causing pathogen or vaccine. The red zone represents the spread of the disease. Infected individuals are shown in red. The characteristics of the spread of every pathogen, virus, or bacteria are unique. Coverage of 50%. Now let's look at the same situation, but this time with 50% of the population having received a vaccine. This would be termed as 50% vaccination coverage. Vaccinated individuals are circled in green. The propagation of the disease is totally different. The individuals on the right have been protected. In the end, part of the population was protected directly by the vaccine, as expected, and another part of the population was protected because it was not exposed to the disease.
So as you're seeing here, because those with the vaccines are the ones in blue, and because we had so many people with vaccines, up to 50% of the population, it means that, so even if this person got sick, this person was only able to pass it on to others, but it could not pass through here to get to over on this side of it. And that is what herd immunity is. So because some people, a large enough volume of the population is vaccinated, it actually protects other people from getting the disease.
It is the surrounding individuals that block the spread of the pathogen. The phenomenon that provides this extra protection is called herd immunity. Here, the individuals protected by herd immunity appear inviolate. Coverage of 80%. In the third hypothesis, the level of vaccination coverage is brought up to 80%. The spread of the disease is rapidly halted. Herd immunity is in full swing, and a large part of the population is protected either directly or indirectly. This is the reasoning for high vaccination coverage. Indeed, High vaccination coverage directly protects those who can be reached by the healthcare system and indirectly protects those who are less advantaged and cannot be reached. This is why vaccines play such an important role in public health policy.
So as you can see here, because we had 80% of the population vaccinated, as in those with the green, even if there was one person who was sick, because there were so many people that were vaccinated around that person, that then that disease cannot jump, basically. That is what herd immunity is. And that's why it is so important to have a large enough proportion of the population vaccinated to prevent those who are not vaccinated from getting sick. So that was it for the points that I wanted to raise. If there are any questions or there are any concerns, please type them, and I will try my best to respond. Again, you can share this live to other people who are interested, who have asked questions about vaccination. Please share this with them so that they have information. If you jumped in the live late, of course, you can go back and review from the beginning, because I started by talking about how much vaccination actually happens in Trinidad and Tobago in children, and that we have such high rates. I showed a video about how vaccines work. I showed a video about how science has evolved. So the vaccines that they are trying to find now as it relates to COVID-19, why does that process seem to be going so fast? It's because of the new technology. I also spoke about the COVAX, which is what the Minister for Health spoke about, and why we are putting money into it now, even though the vaccine is not available. And I don't know if it was said, yes, it was said in the video, but we are putting money into it because what we are putting money into is really the development. So we are putting money into a pool to help the development of it, so that when the vaccines finally become available, we would all have access, equitable access to it. And as he said, as the minister said, or as the video said, what we are looking at is for each country to be able to get access to vaccines to cover 20% of their population, basically whether they could pay for it or not. So it's a situation to ensure that we have equitable distribution of vaccines when the COVID-19 vaccine is available. And then I finally rounded up by talking about what is herd immunity and why herd immunity is so important, and why we actually need large enough volumes of people to be vaccinated for herd immunity. I didn't plan to talk about it, but I think I'm going to very quickly. I'm going to talk about the flu vaccine, because right now the Ministry of Health is actually pushing for us to get the flu vaccine. And we have to take the flu vaccine every year, because it seems like the flu, the virus that causes the flu, actually changes every year. So if you take a vaccine last year, it actually is not going to work this year, because the virus itself has mutated. The virus itself has changed a bit, and how our body responds has changed a little bit. So we have to then take a new flu vaccine every year. The thing about this year, though, in Trinidad and Tobago, we have not had, in previous years, we've only had very small volumes of people dying from the flu. We've only had, 20, 30, 40, 50 maybe people die from the flu every year in Trinidad and Tobago. The number is really minuscule. In the United States and so forth, you end up getting thousands, tens of thousands of people dying. Now, what they are afraid of is that this year, because we have COVID and the flu, they don't know how these two things would interact. And what they are afraid of is, because these two things may interact and may interact badly, that we need to protect people from the flu, so that even if they get the flu, so that even if they get COVID-19, they're not battling the two things, because we don't know how bad it's going to be if you end up with the two, COVID-19 and the flu. So that's why they're pushing, particularly people who are in vulnerable people, elderly, healthcare workers, those who are immunocompromised. They're pushing for those people to get the flu vaccine now, because it is available. We have thousands available in the country, free of charge. You just have to call your health center, the health center that's closest to you, call them to find out when they do vaccinations, and you just show up and get your vaccine. And I would also recommend, again, because 2020 is one of those years, I don't want us to find out a month from now, 2 months from now, that we have doubled the number of people who are dying because those people have the flu and COVID-19, and the effect of having both is so horrible that we don't know what to do, right? Again, 2020 is just 2020 is that 2020. For those of us who survive it, thank God at the end of it. So because of that, we really, really have to push to do things that we may not have normally done to ensure that we put ourselves in the best position. Again, it's important to know that even if you take the flu vaccine or any vaccine, you may actually feel a little sick right after you've taken it, but that is actually your body's response to show that yes, it is working the way it should work, and your body is responding and going through the mechanisms for making the vaccine work, or this is proof that the vaccine works. All right, guys, so that's it. I don't want to be too long. If there are no questions, then share the live to others who may be interested in what I had to say. And you can message me, you could WhatsApp me, you can, and I will try to answer you as much as I can. All right. Thank you so much. Again, thanks you for tuning in, and I will do another live when I feel that there is something else that I need to talk about. All right, chat soon. Bye.